mean? And what I mean by that, see this a sub n? We're calling this the term I want. This is the term I'm looking at right now. That could be the 5th term, the 8th term, the 100th term. This is just the term I'm looking at. In plain English, I want to know what a sub n minus 2 would be if a sub n is the term I'm looking at. And who wants to take a shot at just tell me what this means in just kind of plain English? Ross.
2 terms previous to a sub.
That is 2 terms previous to the one I'm looking at. So that is 2 terms previous. It's important just to be able to look at it and know what I'm talking about. So that means if I'm looking at 8, I'm just going to go 2 steps back, and that's the one I'm going to talk about. So what does n plus 3 then mean? Yeah, no.
3 terms after.
3 terms after, yeah.
Actually, you still going for 30 seconds.
Okay.
Thank you.
Well, good thing you had that answer. That'll be 3 terms after. So let's say I'm looking at the 10th. I would then look at the 13th. That's when it says focus on. This would obviously be 100 after. We're not going to deal with 100 after, but that's exactly what that would be. That would just be 100 terms after. That's a bit aggressive. We won't be looking at anything that I make you write out 100 terms and then have to look at it. But just for reference. All right, now use this as reference. This information when I go over one of your homework questions / problem / one that someone will probably ask. And that is number 13. Was it number 12?
No.
Okay. If we look at number 13, 13 says, super tiny apparently, it says that d sub 1 equals 3, and then it says d sub k plus 1 equals 2 times d sub k minus 1. So it is not d sub k minus 1, it's d sub k, take a breath, minus 1. There's a difference between d sub k minus 1, because that'd be k minus 1. I'm going to say this is d sub k, take a break, minus 1. I get out of that. All right. So if I have to list the next few terms, we'll have d sub 1 equals 3. I didn't know that was that funny. All right, we have our first term equals 3. Now, what can confuse people is they're like, well, this is looking at a future term. It says the term after k is the one I'm looking at. But if we put it in plain English, then we'll put it as the mathematical equivalent of it. But in plain English, this is always the term I'm looking for. So if I'm looking for my next one, which is d sub 2, d sub 2 is actually right here. This is the term I'm looking for. Well, if this is the term I'm looking for, k is 1 less than that. Because k plus 1 and k are 1 away from each other, but this is 1 less. This is the exact same thing as if I'd say d sub k, and this is d sub k minus 1. Down here. This is saying the term I want, this is the term right before it. So that means when I work this out, it should just be 2 times the quantity, the term before it, minus 1. Now, mathematically, it'll look something like this. In order for this k plus 1 to be 2, that k would have to be 1. So this would equal d sub 1 plus 1, which would then equal 2 times d sub 1 minus 1, but that's exactly what I said. It was the term before it. D sub 1 is right before it. It is 1 less than k. So in this case, we would have 2 times d sub 1 would be 3 minus 1, which would just equal 6. When I get to my third term, following this pattern, it should be 2 times the term right before it minus 1. Matching up with those k's, d sub 3 could be rewritten as d sub 2 plus 1. 2 plus 1 is 3. that means 2 is taking the place of my k's, which is going to equal 2 times, well, 2 took the place of this k, so 2 has to take the place of that k. So we'll have d sub 2 minus 1. But in plain English, that was 2 times the term before it minus 1, which is going to equal 10. I feel like I missed one. Oh, that should have been, yeah, this should have been 4. Because that would have been 2 times 2, which is 4, which would have changed this one to 4, which would change this one to 6. The next one is 10, though. So the next one would be the exact same thing. It'd be 2 times 6 minus 1, which would be 2 times 5, which would be 10. And as soon as you see the pattern, the quicker it is you see the pattern, the quicker it is that you can stop trying to figure out what k's value is and just be able to go, okay, it's just 2 times that term before it minus 1. And that's all I expect you to write. All right, once you see the pattern, you can just skip to writing this. Are there questions on what I did here or what was going on? I see confused faces, but no one's asking any questions. Yes?
So for like the 3 minus 1 and 4 minus 1, is that just from the second part of it?
Yep, I pulled it from, so if we look here, we had the term before it. So I just take the term before it and replace it in there. Same thing here, I had d sub 2, which is just the term before it. I just take that 4 and plug it in there. So in plain English, the term I want equals 2 times whatever the term was before it minus 1. Yeah.
Did you record yesterday's class and put on Google Classroom?
Yeah.
Okay.
You gonna watch it again or read it?
Probably.
Oh, okay. Other questions on this one? Because this is probably the hardest one with the patterns. Okay, then the other one I want to go over is number probably 6. 6, 7, and 8 are almost the same thing.
Which one? There's 2 numbers.
I'm sorry, 6 on the back side. On page, is it a 38? Page 38? 42. That's way off on everything I do today. All right. So this is actually from another assignment. So it was out of a different part of the book. But anyway, number 6. That's super tiny still. All right, number 6 says, do 2n minus 1 factorial over 2n plus 1 factorial. Now, here's the problem with this. You really have to understand what it means to be a factorial. If I say 8 factorial to you, I bet you any money everyone's going to recite 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But what you're really reciting to me is 8 factorial equals 8 times 8 minus 1 times 8 minus 2 times 8 minus 3. And you might not think that's mind-blowing, but it is the whole key to being able to solve that problem above, being able to see that that's what factorials are. Factorials are subtracting 1 every single step. Whether that's a number or whether that's 2n minus 1. So let's use that fact to talk about 2n plus 1 factorial. If I needed to rewrite that as the whole thing, that would be 2n plus 1 times. Now here's the thing. We just need to subtract 1 from this to get to the next step. So we have 2n plus 1 minus 1, which is then going to just equal 2n. Then my next step is subtract 1 again. So I have 2n. To get my next step, I'm going to subtract 1 and get 2n minus 1. And then we'd have 2n minus 2, 2n minus 3, 2n minus 4, 2n minus 6, so on and so forth. So It will stop whenever I tell you to. No. Mary.
So let me think that. For 6, then why didn't you do 2n minus 1, like just 2n minus 1? Why didn't you do the same thing?
We won't have to. So that's why I don't care where it stops either, Mark, because we don't know where it stops. We don't know what n is. We don't know when it's going to reach 0. But you're going to see something cancels out. So let's look at the numerator really quick. The numerator is 2n minus 1 factorial, which is 2n minus 1 times 2n minus 2, because I would subtract 1 from it, and we'd keep going. This right here is the exact same thing as right here. My next step here would be 2n minus 2, 2n minus 3. Right here and right here are the exact same values. Something over itself is going to turn to 1. So now I'm going to actually rewrite the fraction. I'm going to leave 2n minus 1 factorial on top. On the bottom, I'm just going to do the first couple steps. 2n plus 1 times 2n times 2n minus 1, and I'm going to stop there. Because I can now stop there and put a factorial symbol after that. Because at any point, you can just stop and put a factorial. Like 8 factorial would be written as 8 times 7 times 6 factorial. Because that would be 5, 4, 3, 2, 1. Well, if we look at the 2n minus 1 factorial, and it's 2n minus 1 factorial, they will turn to 1. And we're going to be left with 1 over 2n times 2n, which is 4n squared, plus 2n. And that would be the end of this problem. I didn't care where they ended because they ended up canceling each other out wherever they end. And that's how every one of these problems work. You're going to find that factorial that's bigger than the other one. 2n plus 1 is bigger than 2n minus 1. Work your way until it starts looking like the top one. All right, those are the two problems I'm going to go over, but I can always go over more. You just have to ask questions. What questions do we have from the homework? ¿Qué pasa? Oh.
Well, why do we need to learn this?
Why do you need to learn this?
No, I was actually thinking the same exact
Like
thing when I was doing
It
this.
seems like so random and out of the blue and like
It's just like finding formulas for patterns.
Weird. Like math is formulas for,
Yeah,
that's
like-
what math is.
Really
Math is about problem solving.
Factorial, like, being factorial.
Mary, give a valid question.
Yeah, I found in general related to the one where you could find the terms it asks for. So for number 5, oh wait, never mind. Sorry, I figured it out.
Okay, awesome. Awesome. No, I just don't think it's a valid question as in a pre-calc class while you're learning it, because at this stage it just is problem solving. It is us gearing you towards the next phase. It's gearing you towards tests. It's gearing you towards what colleges want. This is what they want. They want pattern recognition. They want problem solving. And that's exactly why any job you go to looks at math scores. They're not necessarily going to care that you know what the unit circle is. They care that I can give you a unit circle and you can problem solve your way through it. You can study and you can work hard. Mary.
Number 8, please, because I found most of it, and then I had
On the back side or the...
front side.
Okay, yeah.
So I said a sub n equals 3 plus n minus 1 times 4 because like,
We'll do that today.
okay.
We're going to look at that one problem and we're going to expand it to almost an entire lesson. All right, if you still have that question after today, bring it up at the end. Other questions? Okay, like I said, I'm not going to collect this. This is going to give you a good opportunity to look back at it if you didn't quite finish or understand it. Look at the problems that are around the ones I just did to see if they make more sense. As I said in the beginning of this isn't a super easy lesson. But how you react to it is going to be how successful you are in this. If you just goof off and you don't try on these homeworks and you just copy down answer key stuff and you get the points for the homework, you're going to bomb on this test. Several of you will bomb on this test because of that one fact. You're not trying and you just look at answer keys. If you struggle and you ask questions, this section will be an easy test for you. It is a self-fulfilling prophecy on this. If you can't do it, then you can't do it. If you think you can, and you try and you ask questions, then it won't be that bad. And like I said, today will be a step back, and this should be a pretty easy lesson. All right, today we're going to focus on one thing, and that's the one that Mary asked, and that is arithmetic sequences. So it's just one sequence we're going to talk today. It is the most basic of our sequences. So an arithmetic sequence is a sequence whose consecutive terms have a common difference. Now you can read that whole paragraph. Not really a paragraph, it's just like a sentence or two. But in short, what that is it's saying like 2, 4, 6, 8. That I can just add a number over and over and over and I get the other terms. Or I can subtract a number over and over and over. That's all it's saying. We just call that number a common difference, or D. So we're looking for sequences that you can add the same number over and over and over, and that will automatically make it an arithmetic sequence. So for example, we have 1, 5, 9, and 13. This is what we're going to do to almost every sequence. You're going to see, is there a number I can keep adding to get to the next digits? In other words, to get from 1 to 5, you just add 4. To get from 5 to 9, you add 4. To get from 9 to 13, you add 4. Because we keep adding 4 over and over and over, that is an arithmetic sequence. And more importantly, it's an arithmetic sequence where D equals 4. And remember, D is just your common difference. Yeah, let's just end there because I don't have a lot of room. Sometimes arithmetic sequences hide in fractions. What I mean by that is we have 1, 7 over 6, 4 over 3, 3 over 2. It doesn't look like you can add anything to get each of those. However, in order to add something to a fraction, you have to have a common denominator first. So what you're going to do if you have fractions and you think it might be arithmetic is you're going to come up with a common denominator with all of those. A common denominator of this one is going to be 6. So we're going to change 1 to 6 over 6. We're going to have 7 over 6. We're going to have 8 over 6. And finally, we are going to have 9 over 6. Now we can look at it and say, okay, I'm adding 1 in the numerator. My denominator is staying the same. So between each of these, I'm just adding 1 over 6, 1 over 6, plus 1 over 6. So yes, this is arithmetic. And more importantly, the common difference is 1 over 6. Make sure when you're looking for a common difference, you try it on every single one of them. For this one, we can see we add 3 to get from 1 to 4. But then I have to add 5. And then I have to add 7. Because it's not the same number, it is not arithmetic. And you don't have to go any further than that problem today.
So arithmetic is only if it's adding
The same number. It has to be the same number.
Okay.
And it can't be, because if I went down one more level, it would be plus 2, plus 2, plus 2. Still not arithmetic. So make sure you check all of them. So sometimes it'll be plus 3, plus 3, plus 3, plus 4. And as soon as you have one different, it's not arithmetic. One hitch breaks the whole thing. It has to be this exact same number. That's how you get your common difference. All right, as soon as you know it's an arithmetic sequence, you need to know two things. The first term and the common difference. If you know those two things, you can easily come up with a recursive and explicit formula. So the first thing we're going to talk about is recursive. For a recursive, it's just going to be a sub n equals a sub n minus 1 plus whatever your common difference is. So as soon as you know your common difference, you plug it in that thing. So it's 4. This would just be a 4. If it's 5, That's just a 5. Recursive is pretty easy. However, you do have to state your very first term. So you need to have a first term. Either a first term or a starting point. All right, explicit isn't that much harder either. Explicit is going to be just a sub n equals your very first term plus your common difference times n minus 1. So the only things you're plugging in here is your first term and your common difference. Everything else stays the same. Just like this one, the only thing you're going to do is plug in your first term and your common difference. Everything else stays the same for every single problem. Mary?
Are these like finding the same thing, just depending on what's given to you?
No. These are finding two different types of formulas. Recursive is dependent on knowing the term before it. So in order to get to like the 10th term, I would have to add 5 over and over and over. Explicit is, as soon as I know what, like say it's a sub 5, I just plug a 5 in there and I can get the exact thing. Yep. Another way to write your explicit formula, and this isn't any different than what's above, it's just you distribute the common difference to both of these, which would turn into d times n plus, and then we'd have a sub 1 minus 1, but it's all coming from the same thing. Because if I distribute this d here, I'd have d times n. And if I distribute the d here, I have negative d. So I just write the d times n out front. Oh, I'm sorry, this should have been a d. That should have been a d. A sub 1 minus d. But it's the same thing. And you'll see when I do the problems, I usually start with this one, and then I just change it into this one. This one is just a little easier. It looks more like what we deal with, like the 3x plus 2 or something. All right, examples. Determine whether each sequence is arithmetic. If so, write two formulas. Anytime I ask for two formulas, I'm asking for a recursive and explicit. Those are the exact two formulas I need. So our first formula is, or sequence is 3, 7, 11, 15, 19. First thing I have to do is determine whether it's arithmetic or not. So you're going to say, well, 3 to 7, you just add 4. From 7 to 11, you add 4. From 11 to 15, you add 4. From 15 to 19, you add 4. Yeah, that's arithmetic. I'm adding the same number over and over and over. As soon as I recognize it's arithmetic, I'm going to find my common difference, and I'm going to find my first term. My common difference is a positive 4. And my very first term, a sub 1, equals 3. For an arithmetic sequence, that's all you need. Our recursive formula is going to be a sub n equals a sub n minus 1 plus d. But before I write all that stuff down, I'm going to first write down my first starting point. A sub 1 equals 3. You need that. You need to know where your sequence starts. Then we're going to write our a sub n equals a sub n minus 1 plus 4. Our common difference is 4. That is our recursive formula. That's it. It says start at 3. Our next term is going to be the term before it, which would be the 3 plus 4. So 3 plus 4 is 7. Yeah. So our check over here, I'm not going to write the check out every single time. You should at the very least check in your head. Make sure these numbers are correct. So if I was checking this one, I would say a sub 1 equals, not 1, but it equals 3. A sub 2 is going to equal the term before it, which would be 3, plus 4, which would equal 7. My third term would be the term before it, which is 7, plus 4, which equals 11. Typically, if you get the first 3 right, then the rest are going to follow too. It's just adding 4. In fact, most of the time I don't check my recursive because you just know. Explicit, I'm going to check every single time though. Our explicit formula is going to be a sub n equals my first term, which is 3, plus our common difference, which is 4, times n minus 1. Or we can distribute that 4. 4 times n is 4n. 4 times negative 1 is a negative 4, plus 3 is going to be a negative 1. Both of those are the same equation. To check this one, I just randomly pick out some terms that it should equal. So for example, I might say my fourth term should equal 15. So if I plug a 4 in here, I should get out 15. So a sub 4 is going to equal 4 times 4 minus 1, which equals 15. That is correct. Maybe we'll try the fifth term. Our fifth term would be 4 times 5 minus 1, which would be 20 minus 1, which is going to equal that 19. So both of the checks worked out. Both of my formulas are correct. It's a good method to do in case you kind of forgot. If you get to the test and you're like, I don't remember, is it the D that comes first or the A? Try both of them, check your answer, and see which one works. All right, next one. Next one, the only difference is our common difference will be a negative. A negative common difference is still arithmetic. So in this case, we have 5 to 3 would be negative 3. From 3 to negative 1 would be a negative 3. Negative 1 to negative 4 would be a negative 3. It is arithmetic. It's arithmetic, so I'm going to note my first term is 5, and my common difference is negative 3. That's all you need for recursive and explicit. So any problem that gives you your first term and your common difference, you can immediately write your formula for. I say that because there sometimes are problems that just say you have a common difference of negative 3 and your first term is 5. Write the formulas. It's as easy as plugging it in. Your recursive is going to be list your starting term. A sub 1 equals 5. Our formula is going to be a sub n equals a sub n minus 1 plus our common difference, which is negative 3. So in fact, it would probably just be minus 3 would probably make it easier to write than plus negative 3. Our explicit formula is going to be a sub n equals my first term, which is 5. Our d is negative 3, so it's going to be minus 3 times n minus 1. Once again, you could simplify that to being a sub n equals negative 3 times n is negative 3n. Negative 3 times a negative 1 is actually a positive 3, plus 5 is 8. I'm going to stop right there. Is anyone confused by how I get from here to here? I just want us to know that this is the exact same formula. It is just me distributing that negative 3 to there and there and simplifying. It really is just simplifying that equation. Then off to the side, I'd probably, in my head or on the paper, actually check to make sure it is correct. So like try that third term. My third term should be negative 1. Well, negative 3 times 3 would be negative 9 plus 8 is a negative 1. I'll at least check one of them. If I'm going to check one of them, you should at least check one of them, right? Especially on a test. All right, the last thing we have is 2, 6, 18, 54. I already know it's not arithmetic because I didn't give you much room to do anything on it, but let's just check. We have 2 to 6 would be plus 4. 6 to 18 would be plus 12. I don't need to go any further. That is not arithmetic. Mary.
So I didn't notice though, like each number is multiplied by 3.
Absolutely.
Because that's even total.
It's going to be a geometric sequence, which we're not going to talk about for a couple days.
Okay.
Right now, we're just worried about, do they add? If they don't, today we can just stop at that point. Okay, that's not arithmetic. All right, the last thing we're going to talk about is the same thing, just in a different form. They give me a sub 3. My third term equals 15. My eighth term is 50. Come up with two formulas. The other important part was it does say it is in fact an arithmetic sequence. So that means there is in fact a common difference to get from each stage. You need to know that in order to solve this problem. So we're going to start out going the hard way about this. we're going to go, okay, my first term is, I don't know. Second term, I don't know. Third term, that's 15. Then we have a whole bunch of I don't knows. Fourth term, I don't know. Fifth term, I don't know. Sixth term, I don't know. Seventh term. Eighth term, I know that one. That one equals 50. So we have a bunch of things we don't know the values of. The key to this is we do know there's a common difference between each of these values. So if I needed to get from a sub 3 to a sub 4, there is one number I would add to it. I would use that same number to add here, same number to add here, same number to add here. So in other words, I would, to get from 3 to 4, I would add some common difference. Then I would use that same number to get from 4 to 5. I would use that same number to get from 5 to 6. I would use that same number to get from 6 to 7. And I would use that same number to get from 7 to 8. That means to get from 15 to 50, I'm going to take 15 and add D plus D plus D plus D plus D. In other words, 1, 2, 3, 4, 5 common differences. That means 15 plus D plus D plus D plus D plus D, probably easier to write that as 5D equals 50. There is an easier way to get that 5 though. If I just look at 3 to 8. So this is the much easier way to do that. To get from 3 to 8, that is just plus 5 steps. So probably easier than writing out all those is just go, okay, there's 5 steps between 3 and 8, so 15 plus 5 steps equals 50. So now we just solve for D. That means we subtract 15 from both sides. We'll have 5D equals 35. And finally, we'll have our common difference is 7. We need 2 things to come up with our formulas. We need a common difference and the first term. Yeah, Jake.
Which is going to be 2. Wait, 1.
It's going to be 1. It's going to be 1. Let's talk about 2 ways to do that. First way. Jacob, what did you do to get yours?
I subtracted 14 from 15.
Yeah, you subtract 15. You subtract 14. I'll say it correctly. You take 15 and you subtract 14. In other words, you start at 15, you subtract 7, and you subtract 7, and you come up with your a sub 1 equals 1. That is a very nice preferred method where you just have a sub 1 equals 1. Here's the other method to figure out what your first term is. We can come up with kind of a generic formula, i.e., a sub 3 needs to equal my first term plus my common difference times n minus 1. That is just our explicit formula with the only value I plugged in is a sub 3. Well, we know a sub 3 is 15, and that would make my n 3, and we also know our 7 there. So we can plug in a bunch of information. We could say a sub 3 is 15. Let's pretend we don't know our first term. Plus our common difference is 7. Our n would be 3, because I'm looking at my third term. Well, that's going to be 15 equals a sub 1 plus 7 times 2 is 14. Subtract 14 on both sides, you come up with a sub 1 equals 1. Is that the easiest way to do it? Sometimes it is, not in this case. But imagine if I gave you a sub 101 and a sub 150. I don't think I want to go step back that many times to get my first one, so I most likely just set that up to solve it. You can count how many steps there are to get to 1, but generally speaking, you'll mess up a lot of times. This is very useful if you're really far away from 1. If I'm only 2 steps away, I honestly will just subtract 7 twice. All right, either way, you get your first term, which means we can do our recursive. Our recursive is just a sub 1 equals, we determine that's 1. And we're also going to do our a sub n equals a sub n minus 1 plus our common difference, which is 7. Our explicit formula would be a sub n equals my first term, which is 1, plus my common difference times n minus 1, which is the exact same thing as if I distribute that 7, I would have 7n. 7 times negative 1 is a negative 7, plus 1 is going to be minus 6. That is my explicit, that's my recursive formula. And that is all we're going to be covering today. Yes, Nicholas?
So if we're only given 2 terms, could we assume that it's arithmetic?
Yes.
Okay.
Yep, especially in this section. When we start learning more of them, then if I don't put it on there, you're going to have to think, is it geometric, is it arithmetic, is it something else? But yes, as of today, if I just give you 2 terms and ask you for a recursive and explicit formula, you can assume that it is in fact arithmetic. Mary, do you think that's going to help you on that problem? Was it you that asked the one on the homework? Yeah. Are there any questions for me? Like I said, this was kind of a step back from what we did yesterday. I threw a bunch at you yesterday. Now we're just focusing on one thing, arithmetic. Then we'll talk about summations on Monday. Then we'll go into geometric, which is going to be multiplications. And then we'll probably step back and look at kind of what we did yesterday. We'll talk more about factorials and other types of sequences. All right, the rest of the time is yours. I was hoping to give you more. I didn't.